Hi everyone, this is Teruli Tutoring. Welcome back to my channel, or welcome to my channel if this is your first time here. Today's video we're going to be covering an introduction to absolute value, and this serves as the second video in my advanced function series for Ontario students. We are going to be going a bit more in depth than other videos I'm making about absolute value, but so far this is just an introduction. So without further ado, let's get started. So let's start off with a definition of absolute value. The absolute value of a number is always a positive number. You can see me underlining it now. This is a very important concept. It is basically the entire concept of absolute value. And when we are notating absolute value, we want to write it as these two vertical lines and then whatever we are taking the absolute value of inside those vertical lines. So in this case, I just underlined it on the screen. We're taking the absolute value of some variable x. So we put these two vertical lines and then put x inside. So underneath that, we can see that we're taking the absolute value of 5, and the answer we get for that is 5. And then we take the absolute value of negative 5, and we also get 5. And this is because, again, we cannot have a negative value for absolute value. And the reason we can't obtain a negative result when we take the absolute value of a number is because absolute value can be described as the distance from 0 on a number line. Negative 5 and 5 are both 5 units away from 0 on a number line, so we're not going to have a negative value when we take the absolute value. We can't have negative distance, so it wouldn't make sense to have a negative result when we take the absolute value of something, because absolute value is basically saying how far this number is from 0. And we should know, again, from our previous math courses, I'm kind of repeating myself, I'm sorry, that we shouldn't have negative distance. So, moving on. Let's try some examples now. In our first example here, we are trying to evaluate what the absolute value of negative 5 minus the absolute value of negative 8 is. So we know from the previous explanation on the last slide that the absolute value of negative 5 is 5 because we cannot have a negative number for absolute value, and the same rule would apply to negative 8. So we know that the absolute value of negative 8 is going to be 8. So our first step in evaluating this would be to write to evaluate the absolute value and then write that out. So we would say 5 minus 8, as we have now evaluated the insides of the absolute value. And then we're just going to subtract normally. And 5 minus 8 is negative 3. And that would be our answer. So you can just see I'm writing out negative 3, and I'm going to circle it, and we are done. Okay, so here in this next example, we have an equation that says the absolute value of some variable x is equal to 4. And right off the bat, it might be very easy to be like, okay, this is very simple. X is equal to 4. That is the value of x. That makes this equation true. And you're not entirely wrong if you're thinking like that, and I understand the thought process you're going through. However, when we are thinking about absolute value, we are thinking about the distance from 0 on a number line. And although if you travel from 0 to 4 on a number line, you will be covering a distance of 4 units, and that's why you're thinking correctly if you made the previous assumption I described. If we also travel from 0 to negative 4 on a number line, we will still be covering a distance of 4 units. So this particular equation actually has two solutions, which you can see I'm writing out now above. So when we're solving something like this, there might be one solution, there might be two solutions, or there might be no solutions. So we always kind of have to take those possibilities into account when solving equations for absolute value. And I'm also now just drawing out this solution on a number line because sometimes your teachers might require you to do this. I'm just making two little points in the number line to represent 4 and negative 4. You don't always have to solve it like this. Just thought I would draw it out to illustrate what it looks like. And we are done solving this question, and let's move on to the next example. So in this example, we have something a little bit more difficult than the last example. Basically, we're saying the absolute value of some variable x sub minus 1 is equal to 8. So when we're going to solve something like this, again, we want to take both kind of scenarios into account. Whatever value we have inside of the absolute value is either equal to 8 or it's equal to negative 8. Because remember, once we take the absolute value of negative 8 or 8, we will get a resultant resultant answer of 8. So again, we have to consider that. So what I'm going to do is I'm going to write out both scenarios, and then I'm going to solve for both variables in each scenario. So I'm going to write x minus 1 is equal to 8, and then I'm going to write x minus 1 is equal to negative 8. I apologize for how ugly the x on the right looks. I can't draw perfectly either. Anyway, so I'm just going to solve each of these. So for the equation on the left, I'm just going to bring negative 1 over like I would solve a standard equation. This is something we've done many times before throughout grade 9 to grade 12. So x will be 9 if we solve that equation, and then for the other equation, x will be equal to negative 7. Again, I'm just rewriting the 7 now because I drew it kind of ugly before. And that's pretty much it. Those are the two solutions for this. I'm just circling them or boxing them off, sorry. And we are done. Okay, so before we start this next question, I'm just going to throw up a little disclaimer and a little apology because at the top of the screen it says example 5 and it should say example 4. So yeah, that's on me. I'm editing now and I realized my mistake. Please don't hate on me. I'm sorry, okay? Anyway, back to the question. Basically, this question or this equation is asking us to determine for what values of x is the statement above or the equation above true. And the equation above says that the absolute value of x plus 2 is equal to negative 5. And your initial intuition upon seeing this might be, well, I'm going to divide this into two cases and I'm going to solve for x just like we did in the last question. And that honestly wouldn't be a bad idea because, like I said, we did it in the last example, and it might be a good way to approach something if you don't know what you're doing. However, if you look closely at this problem, it's saying that the absolute value of some value of x plus 2 is going to be negative 5. And if we think back to the definition of an absolute value and how we talked about how an absolute value can never be equal to a negative number, we know that this is not possible because we can't evaluate the absolute value of some number and then get negative 5. So this equation here actually has no solutions. And you can see I'm going to be writing it in big capital letters across the screen that there is no solutions for this equation. And this is a key example of why it is important to always pay attention to what the question is asking of you. And we are done. Let's move on. Okay, so now that we've dealt with some examples that have absolute values inside of equations, we are going to move on to inequalities, linear inequalities, so nothing too complex. But in this inequality up above, it says that the absolute value of x is less than 2. So when I like to think about this, I like to picture a number line and think of from which points on the number line would I get an absolute value that is less than 2. So I'm actually drawing out the number line now, and I'm drawing out negative 2 and 2. And I know that for any value of x within this line, I am going to be getting an absolute value that is less than 2. But for instance, if I took the absolute value of, let's pick a random number between negative 2 and 2, let's say negative 1. The absolute value of negative 1 is going to be equal to 1. Is 1 less than 2? Yes. So we know that this range works and that this is a correct answer. But let's just do another one for positive numbers. Say I took the absolute value of 1.5. Absolute value of 1.5 is 1.5. Is 1.5 less than 2? Yes, it is. So we know that this is the correct answer. So here I wrote out my answer on the number line, but sometimes your teachers want you to write it in another form. So I also wrote negative 2 is less than x, which is less than 2. And that, in this case, would be the solution to this particular inequality. So we are done. Let's move on to another example. Okay, so in the last example, we dealt with the absolute value, inequality of the absolute value where x is less than 2, whereas in this problem, the absolute value of x is greater than 2. So we're basically going to be doing something very similar to what we did last time, but in this case, x is going to be greater than 2. So like last time, I'm drawing out a number line, and I'm trying to visualize the points from which x is going to be greater than 2. You can see that I'm drawing open circles because we are not being inclusive of x. I'm now thinking back and hoping that I did that for the last question. If I didn't, the circle should be open. Anywho, so I am writing 2 on one end, and then I am coloring in the side because I know that all the numbers that are greater than 2 on the right side of the graph are going to result in an absolute value that is greater than 2. And then I am also drawing a little open circle on the left side of the graph. And when I say left side, I mean past, like wherever 0 would be. So like 2, positive 2 is obviously to the right of 0, and then negative 2 is to the left of 0. So I'm going to be writing negative 2 to the left of 0, and then I'm going to be coloring in all the values, all the possible x input values that are to the left of negative 2, that if I were to plug in any of those for an x value into this inequality, I would end up getting a number that is greater than 2. And just to kind of prove the point here, if we were to take a number, for instance, let's say negative 3, we were to take negative 3 and evaluate that. The absolute value of negative 3 is 3. 3 is greater than 2, so we know that all the values on the left side of the graph are going to hold true. And then say we were to take the absolute value of 4, which is a value from the right side of our number line. Absolute value of 4 is 4. 4 is greater than 2, so we kind of just prove that this holds true. So our solution would be that either x must be greater than 2 or x must be less than negative 2. It cannot be both of these things at the same time. It has to be either one or the other, but that is a solution, and we are done. Okay, so in this example, the inequality says that 2 times the absolute value of x is greater than 16. And this looks a little bit different from anything we've done before because we have this big constant multiple outside of our absolute value of x. We don't want that there. We want to isolate for the absolute value of x. So what we're going to do is we're going to divide both sides of the inequality by 2. So that's what I'm doing on the screen right now. And by doing this, I am going to obtain the result of the absolute value of x is greater than 8. Now, upon looking at this, you can see that it looks awfully similar to what we just solved in the last example. And if you don't know how to solve that, please go back and watch it in case you're confused. But if not, you know that our solution is going to be x is greater than 8 or x is less than 8, like less than negative 8, sorry. And that is our solution, and we are finished. Let's go to the next example. Okay, so this example question looks awfully similar to the one that we just solved in example 8, but I promise you they're actually quite different. Here we're saying that negative 3 times the absolute value of x is greater than negative 27. And we would still solve this in the similar way that we solved the last one. We want to divide both sides of the inequality by 3. However, when we do so, because we are dividing by a negative number, there is this rule that we must flip the side of the inequality. So instead of saying greater than negative 27, we're going to say greater than whatever the result we get after we divide. So once we divide by negative 3, we are going to write that the absolute value of x is less than negative 27 divided by negative 3. And we know that is going to give us the result of 9. So now I'm just going to write that out on the screen. I'm writing that absolute value of x. Sorry, I'm repeating myself, but the absolute value of x is less than 9. And then we would solve that the way we have solved it in the past. Again, if you don't understand, go back and look. But basically, negative 9 is going to be less than x, and x is going to be less than 9. And that is our solution, and we are done. Okay, moving right along, we have this example where the absolute value of x plus 2, which is outside the absolute value. We've dealt with other problems before where we have the absolute value of x minus 1, which are both inside the absolute value. But in this case, the constant is being added after the absolute value has been evaluated. Anyway, all of that is greater than 5. So we want to solve this, and we want to find out for which values this statement holds true. And to do this, we need to take the constant, which is the constant we are adding, which is positive 2, and we are going to move it over to the other side of the inequality. And by doing so, we are basically subtracting it, just like we would do if this was an equation. And we are going to move it over. And so we're going to obtain the result that absolute value of x is greater than 3. And we should know by now, based on the previous examples, how to solve this. But basically, we're going to have two solutions for this, and one of them is going to be that x is greater than 3, and the other would be that x is less than negative 3. And you can see that I'm writing those out now on the screen. And once we have written those out, we have finished solving this inequality, and we are done. Okay, so this inequality is going to be our last example of inequalities involving absolute values. And in this inequality, it says that negative 2 times the absolute value of x plus 3, and then outside of the absolute value plus 14, is greater than or equal to negative 16. And the first step we want to take in solving this inequality is to move over the constant that we are adding. In this case, that is 14. We're going to move it to the right side of the equation, and by doing so, we're going to be subtracting it from negative 16. So it's going to be negative 16 minus 14, which is going to give us negative 30. I'm going to rewrite our inequality with negative 30 now, so it's going to be negative 2 times the absolute value of x plus 3 is greater than or equal to negative 30. Our next step is going to be dividing both sides by negative 2 in order to eliminate the constant multiple. When we divide by negative 2, because it is negative, we have to switch the sign of the inequality. So it's going to be the absolute value of x plus 3 is less than or equal to 15, because negative 30 divided by negative 2 is 15. And now we are going to break this down into cases because we've simplified our inequality. So the first case is going to be that x plus 3 is less than or equal to 15. And then in our second case, we are going to say that x plus 3 is greater than or equal to, I'm rewriting my addition sign, it was a little funky, but x plus 3 is greater than or equal to negative 15. So now I am going to clear my screen and solve these two cases. So like I said, in the first case, it is x plus 3 is less than or equal to 15. The way I'm going to solve this is I'm going to move the plus 3 to the right side of the inequality, and by doing so, I'm subtracting it from 15. So the first solution is x is less than or equal to 12. In the second case, I am going to say that x plus 3 is greater than or equal to negative 15. Similarly, I am going to move that positive 3 over, and by doing so, subtract it from negative 15. So my solution for this will be x is greater than or equal to negative 18. So my final solution will be negative 18 is less than or equal to x, which is less than or equal to 12. And that is our final solution for this inequality, and we are done. Yay! Okay, so now that we've considered what equations involving absolute values look like and inequalities involving absolute values look like, let's consider what the graphs of absolute value functions might look like. At first, I was kind of concerned as to whether or not I should include this into an introduction video to absolute value, but I thought I would at least show you what an absolute value graph looks like, even if I don't go in depth on how to graph an absolute value function. Anyway, so the graph of a standard absolute value function would be the graph of y is equal to the absolute value of x. And what that would look like is basically, it's going to look like a positive like v above the x-axis. And the reason this is going to happen is because basically for half the graph from 0 to infinity, it is going to be, the graph is basically going to be y is equal to x. And then for the other half of the graph from negative infinity to 0, it's basically going to be, the slope of the graph is basically going to be y is equal to negative x. And the reason why we don't have any portion of the graph below the x-axis is because the output point, which is your y value, can never be a negative value, because absolute values, when we take the absolute value of any value of x, like we said before, it's always going to produce a positive output. In that case, our output is y. So for any of our x values, we're always going to have positive y values. And you can just see that I've graphed some common points on the graph here that I drew. Our graph does pass through the origin. It's one of our parent functions. We'll talk about parent functions in a later video, but that does pass through the origin. And you can actually perform transformations to the absolute value graphs. So I'm going to show you how to do that now. So say we had the graph of y is equal to the absolute value of x minus 1. because the -1 is actually inside the absolute value brackets, or the little vertical lines, that means we are going to be doing a horizontal translation, 1 unit to the right. So you can see that the graph is no longer passing through the origin. Instead, that little sharp point is at 0, 1 or 0, 1. And we can also, if we were to add a constant or +2 to the end of this, it means we would be kind of translating our graph 2 points up. We'll do a vertical translation. You can see me drawing a bunch of arrows on the screen here. I don't know exactly what I'm doing. My words are getting a little jumbled, so I think I sound a little wonky too. But basically, you can perform transformations to absolute value graphs. I'm going to have another video where I go a little more in depth on how we would graph absolute value functions. So if you're a little confused by this, don't worry, you just kind of know that this is what an absolute value function looks like when it's graphed, and that you can apply transformations to these graphs. Okay, so that concludes today's content for the video. The video actually ended up being a lot longer than I thought it was going to be, but that's totally fine. I'd rather have a long video that gets my point across than a short video that doesn't help anyone. Anyway, I feel like even though the video is quite long, for my standards at least, I feel like there's still a lot of information about absolute value and different absolute value functions and graphs and all that stuff that I wasn't able to fit into this video, so I will be doing a supplemental video for that. In this video, I kind of really wanted to focus on the Ontario curriculum for lesson 1.2 of grade 12 advanced functions, and only really covering the content that is in that lesson. I didn't want to screw up too many Ontario students too badly by throwing in some bonus freebie information. But if you are still interested, be sure to check out that video with the supplemental information when it does come out. Thank you so much for watching this video if you've gotten to this point. Thank you so much for supporting my channel. I'm just a Ontario high school graduate myself who's just trying to help out some other Ontario students with math and share my love of math in the process. So if you could support me by liking and subscribing down below, it would be really appreciated. And that's pretty much all for this video. I hope to see you in the next one. Bye.